Hello! Today we will be discussing interval class vectors. During our time together, I would like to answer two questions. First, what is an interval class vector? And second, how do I create an interval class vector? Let's begin with a definition. An interval class vector is a list of all possible interval classes, or unordered pitch class intervals, within a given pitch class set. IC vectors are placed in square brackets and have 6 order places corresponding to each interval class 1 through 6 from left to right. The numbers within the IC vector indicate the number of times that each interval class occurs within the set. For the rest of our time together, we will place the interval class vector below the list of interval classes, labeling the order positions within the vector. I'd like to now turn our attention to how to create an interval class vector. First, we have to know how many interval classes to look for. The total number of intervals in any set can be found using the formula n squared minus n divided by 2, where n equals the cardinality, that is, the number of elements in the set. Since trichords have 3 elements, n equals 3. 3 squared is 9, 9 minus 3 is 6, and 6 divided by 2 is 3. There are 3 intervals in any trichord. To make sure you understand how this formula works, go ahead and pause the video here and figure out how many intervals are in a tetrachord, pentachord, and hexachord. Welcome back. If you answered 6, 10, and 15, you are correct. Now that we know how many intervals to look for, let's generate IC vectors for one set of each of these cardinalities. When determining the vector, I find it helpful to put the set in prime form and then identify the interval classes between each of the pitch classes, working systematically from left to right to make sure I don't miss any. Here we have set class 037, the consonant triad. From 0 to 3 is IC3, so I'll put a 1 in the 3 position of my vector. 0 to 7 is IC5. Those are the only intervals from 0, so I'll move over to pitch class 3. From 3 to 7 is interval class 4. Those are the only 3 intervals in this set, so I'll fill in the rest of the spaces with zeros. As a check step, we can make sure that our interval class vector sums to 3, since there are 3 intervals in a trichord. Next, let's try tetrachord 0, 1, 3, 7. Starting from the left, 0 to 1, IC1, 0 to 3, IC3, 0 to 7, IC5. Moving to 1, 1 to 3 is IC2, 1 to 7, IC6, and finally 3 to 7 is IC4. We can use our check step and sum our interval class vector to make sure that it sums to 6, since there are 6 intervals in any tetrachord. You may notice that there's one of each interval class within our vector. That's because 0137 is one of 2 all-interval tetrachords, or AITs. The only other AIT has the prime form 0146. Next, let's look at the pentatonic collection. From 0 to 2 is IC2, 0 to 4, IC4, 0 to 7, IC5, and 0 to 9, IC3. Moving the starting position to the right, 2 to 4 is IC2, 2 to 7, IC5, 2 to 9, another IC5. From 4 to 7 is IC3, and 4 to 9 is IC5. Finally, 7 to 9 is IC2. The interval class vector 0 plus 3 plus 2 plus 1 plus 4 plus 0 sums as it should to 10. The interval class vector also reveals a special property of this set. The pentatonic collection is a deep scale, meaning that each interval class occurs a unique number of times, and these numbers ascend sequentially: 1 IC4, 2 IC3s, 3 IC2s, and 4 IC5s. Now that you've seen a few examples, why don't you pause the video and work through the interval class vector for the whole tone collection. Then resume this video to check your answer. hopefully your interval class vector reads 060603. Remember that your interval class vector should sum to 15 since there are 15 intervals in any hexachord. If you ended up with a different answer, spend some time reviewing the process used earlier in the video and then try again until you come up with the correct answer. I hope you've enjoyed this video today and learned something new. I look forward to seeing you in class.